Okay students, last class geolite is completed. Now we are discussing a new topic, that is silicones. First definition student, the organo-silicon polymers containing silicon-oxygen-silicon linkage. The organo-silicon polymers containing SiO-Si linkage are known as silicones. The organo-silicon polymers containing silicon-oxygen-silicon linkage are known as silicones. Preparation of silicone students. Generally, the silicones can be prepared by using two compounds. One is methyl chloride CH3Cl. Another one is silicon. By using these two, the silicones can be prepared. When methyl chloride, two molecules of methyl chloride react with silica in the presence of copper catalyst at a temperature 573 Kelvin, to form dichlorodimethyl silane. Name of compound is very important student. Dichlorodimethyl silane is the material that can be used for the preparation of the silicone. Once again student, when two molecules of methyl chloride react with silicon in the presence of copper catalyst at a temperature 573 Kelvin to form dichlorodimethyl silane, which is upon hydrolysis to form dihydroxydimethyl silane. Here the mechanism is the two chlorine atom replaced with two hydroxy of the water molecule. The 2H plus ion of water molecule react with chlorine to form HCl. Here lost as HCl molecule. Once again student, the two hydroxyl ion of two water molecule react with two chlorine atoms of silane to form 2-hydroxy. Whereas the two H plus ions of water molecule react with the two chlorine atom to form -2 HCl, lost as a HCl molecule. Here the two chlorine atoms substituted with the two hydroxy groups, and the two H plus ions react with two chlorine atom to form HCl molecule. The brief preparation once again student, when methyl chloride react with silica to form dichlorodimethyl silane, which is upon hydrolysis it can form dihydroxydimethyl silane. Okay students, right. Next one, when dihydroxydimethyl silane upon condensation polymerization, that is the molecules are condensed with one another, combined with one another, which is known as condensation. It can form silicon to methyl group hydroxy and another hydroxy group. It is one molecule, because we are considering two molecules of dihydroxydimethyl silane. Therefore, here also two molecules are present. Here the mechanism is loss of water molecule. That is, the hydrogen of one molecule, the hydroxy of one molecule condense with one another to form minus water molecule. Here what happens? Silicon methyl hydroxy, oxygen silicon methyl hydroxy. Here loss of water molecule will be takes place. Clear student? Here what happens student, in the final structure silicon oxygen silicon linkage will be present. Hence these are known as silicones. The total preparation is like this student. When methyl chloride plus silicon, dichlorodimethyl silane, which is upon hydrolysis, dihydroxydimethyl silane, which is upon condensation polymerization to form silicones. Total 3 steps student. First step is formation of dichlorodimethyl silane. Second step is formation of dihydroxydimethyl silane. Third step is condensation polymerization of dihydroxydimethyl silane to form silicones. Here condensation of two molecules takes place and loss of simple molecule like water will be takes place. Clear student? Right. If you consider two molecules, it is a structure form. For example, 3 molecules, 4 molecules, 5 molecules are present, 5 molecules of dihydroxy dimethylsilane is present, then what is the product form? It is the structure form. Like this, the chain will be continued. 2 molecules it is 3 molecules. If you take 4 molecules, the chain will be continued. The chain will be continued. Hence, this type of compounds are known as straight long chain silicones. Straight long chain silicones. The number of dimethyl dichlorosilanes increases. The length of the silicon oxygen silicon also increases. The silicone chain also increases. Due to this reason, these are also known as straight long chain silicones. Straight long chain silicones. In our examination point of view, only one question they will ask student, that is which type of linkage is present in silicones. Silicon oxygen silicon linkage is present. Another one is most important, what is the starting material that can use it for the preparation of silicones, that is dichloromethylsilane. Very important. Dichloromethylsilane can be used for the preparation of the silicones. Okay student. Next one, the length of the straight chain silicones can be controlled by using trimethyl hydroxysilane. Generally, in the case of straight long chain silicones, the length of the chain will be increases. The length of the chain will be increases. The length of the chain can be controlled by using one compound that is known as trimethyl hydroxysilane. Methyl groups are 3 and hydroxy 1, hence that is known as trimethyl hydroxysilane. How it can control? By using one reaction student. It is dimethyl dihydroxysilane. Here trimethyl hydroxysilane. Then what happens student? Here loss of one water molecule will be takes place. Silicon oxide liquid will be present, well and good. But other side the chain is not present. Why? Because here hydroxy group is not present. Instead of hydroxy, methyl group is present. Hence the chain will be controlled. Therefore, trimethyl hydroxysilane can be used to control the length of the straight chain silicone. Straight long chain silicone. Here what happens student? At the end methyl group is present. If the methyl group is present, further silicon oxygen silicon linkage is not possible, because the chain will be blocked, the chain will be stopped at the stage due to presence of the methyl group. Once again student, the length of the straight chain silicone can be controlled or blocked by using trimethyl hydroxysilane. It is also important student, which compound can be used to block or control the length of the straight chain silicone, that is trimethyl hydroxysilane. CH3 taken thrice, SiOH. CH3 taken thrice, SiOH. Copy this student. Okay students, next continuation, silicones topic, properties and uses of silicones. First one student, silicones, that is these are water repelling in nature due to presence of non-polar alkyl group. The silicones are water repellent in nature, that is hydrophobic in nature. They does not react with the water molecule. Due to presence of non-polar alkyl group. You can observe student, in the silicones methyl groups are present. Due to presence of non-polar methyl groups, they are water repelling in nature. That is SiCl2 CH3 taken twice, SiOH taken twice, CH3 taken twice. In silicones, methyl groups are compulsory, that is alkyl groups. Due to presence of these non-polar alkyl groups, they are water repelling in nature. Next one student, these are high thermal stability, high dielectric strength, resistance to oxidation and chemicals. These silicones are having 4 properties students. One is high thermal stability. Even at a high temperature also, they does not undergo cleavage, that is breakage, and they are having high dielectric strength. And these silicones are resistant to oxidation and chemicals. When oxidizing agent is added, there is no reaction with silicones. Any chemicals are added, there is no reaction with the silicones. That is, they are highly inert, thermal stability and resistance to oxidation. Next one student, these silicones are used in greases, sealants, electric insulators, waterproofing fabrics, surgical and cosmetic appliances. Greases students, We know that the graphite used as a dry lubricant. Just recall that information. Similarly, these silicones are also used in greases. Sealant. Sealant means, for example, in houses we are observing that the ceiling is the ceiling we are observing. Sealing means that temperature does not reaches the earth. The temperature does not reaches the our home or earth by using the sealing phenomena. That is known as sealant. That is known as sealant. The thermocol sheets we are using sealant. Like that only. The silicones are used as a sealant. The silicones are used as a sealant. Next one, student. These are used as high electric insulators. Silicones are used as high electric insulators. That is, the electric current does not pass through the silicones. And these silicones are used in waterproofing fabrics. For example, you are observing waterproof material, waterproof watches, waterproof substance. For cleaning fridges and different kitchen materials, we are using waterproof cloths. Those contains silicones only. Waterproofing fabrics contains silicones. Why? Because first we are discussing water repelling in nature. Due to this property only, waterproof fabrics we are using silicones. Next one, silicone are used in surgical and cosmetic plants. In surgical, like blades and scissors, in surgical instruments we are using. That also silicones are some percentage will be using. Silicones are used in cosmetic plants like beauty parlors, cosmetology, cosmetics. We are using this silicones also. Don't neglect the physical properties and uses, student. In a competitive point of view, which of the following statement is not correct? Which of the following statement is correct? At the time they are asking properties and uses. Okay, students, these are also very important. Don't neglect. Next, student, last concept of this P block element and the 14th group will be the silicates. That is known as silicates. Silicates, first definition, student. The compounds which contains SiO4 minus units are known as silicates. The compound which can contains silicate units, that is SiO4 minus 4 units, are known as silicates. Yes, student, any compound contain these units are present, those compounds are known as silicate. SiO4 minus 4 unit. The structure of SiO4 minus 4 will be like this. Silicon can be bonded to 4 other oxygen atoms. Each oxygen atom carry one negative charge. Because SiO4 minus 4 means the 4 negative charge present on each oxygen atom. These silicates are tetrahedral manner. In these silicates, the 4 oxygen atoms surrounded by silicon in a tetrahedral manner with sp3 hybridization. Here these 4 oxygen atoms arranged in a tetrahedral manner, as well as the hybridization of silicon. In silicates is sp3 hybridization. Very, very important word. What is the hybridization of silicon? In silicates is sp3 hybridization, because tetrahedral arrangement will be present. We know that sp3 hybridization, tetrahedral geometry. Next one, student. The three-dimensional arrangement of silicates will be like this. Here the dot indicates silicon, student. The circles indicates oxygen atom. Here the dot is surrounded by 4 other oxygen atoms. 1, 2, 3. It is the 4 other oxygen atoms. Each oxygen atom carry one negative charge. In examination, they will ask students, which of the following is the three-dimensional representation of the silicone? At that time, it is not correct. It is the correct three-dimensional representation of the silicates. Yes, student. Next one, student. Very, very important in NEET, JEE, as well as KSET point of view. More concentration, student. Compulsory, damn sure one question. This tabular form. This is not there in board point of view, but competitive point of view, they will ask student. That is classification of silicates. The silicates are classified into orthosilicate, pyrosilicate, chain silicate, cyclic silicate, two-dimensional sheet silicate, and a three-dimensional network silicate. Depends upon the number of oxygen atoms sharing between the two silicate units. The classification of the silicates is based on the number of oxygen atoms sharing between the silicate unit, For example, student, if the silicon atom share one oxygen atom, or if the silicon atom share two oxygen atom with other silicate unit, if the silicon atom share three oxygen atom with other silicate units, if the silicon atom share four oxygen atom with other silicate units, then different types of silicates are formed, which is known as oxygen sharing. One by one we will discuss, student. First one is type of silicate, number of oxygen atom sharing, and example. Type of silicate, number of oxygen atom sharing, and examples of the particular silicate. First one, student. Orthosilicate. The silicates in which the silicates in which zero oxygen atom sharing between the silicate units are known as orthosilicate. The silicate in which zero oxygen atoms or no oxygen atom sharing between the silicate units are known as orthosilicate. For example, it is the orthosilicate. Why? Because this oxygen atom does not share any other oxygen atom with other silicate unit. This oxygen atom does not share oxygen atom with the other silicate units. For example, student, the good example is zircon. Zircon is the good example of the orthosilicate. Next one, student, pyrosilicate. One oxygen atom is shared. That is, the silicates in which one oxygen atom of one silicate can share with the other silicate are known as pyrosilicate. The good example is hemimorphite. Second one. Third one is chain silicate. The silicates in which two oxygen atoms are shared between the silicate units are known as chain silicate. The example is beryl. The silicates in which two oxygen atoms share between the silicate units, in a cyclic manner are known as cyclic silicate or ring silicate. Observe, student, the chain and the cyclic silicates are sharing same number of oxygen atoms, but it is a chain manner, it is a cyclic manner. The number of oxygen sharing between the silicate units are same, but in a chain manner, chain silicate, in a cyclic manner, cyclic silicate. Next one, student, two-dimensional silicate. The silicates in which three oxygen atoms are shared between the two silicate units are known as two-dimensional sheet silicate. The example is quartz and feldspar. Talc and throwite are the good examples of the two-dimensional sheet silicate. The last one is three-dimensional network silicate. Here, four oxygen atoms are sharing. The silicates in which all the four oxygen atoms share between two silicate units are known as three-dimensional network silicate. The good example is quartz and feldspar. And glass and cements are also three-dimensional network silicates, but these are man-made silicates. Cement is man-made and glass is also man-made. That's why in PU board point of view, they will ask every year this question, student, that is name any two man-made silicate. Glass and cement are two man-made silicate. In competitive point of view also, which of the following is the example of the man-made silicate? Glass and cement are man-made silicate. Here all the oxygen atoms are shared between the two silicate units. Clear, student? Once again I will repeat classification of silicate: ortho, pyro, chain, cyclic, two-dimensional, three-dimensional silicate. The silicates in which one oxygen atom share between two silicate units, orthosilicate. Two oxygen atoms share between two silicate units. Sorry, student. Zero oxygen atom. The silicates in which there is no oxygen atom sharing between the two silicate units is orthosilicate. Only one oxygen atom sharing, pyrosilicate. Two oxygen atoms sharing in a chain manner, chain silicate. Two oxygen atoms sharing in a cyclic manner, cyclic silicate. Three oxygen atoms are sharing, two-dimensional silicate. All the oxygen atoms are sharing, that is three-dimensional silicate. Depends upon the nature of the silicate, we can define the number of oxygen atoms are sharing. In a competitive point of view, this tabular form is important, student. In a pyrosilicate, how many oxygen atoms are sharing? In cyclic silicates, how many oxygen atoms are sharing? In a two-dimensional sheet silicate, how many oxygen atoms are sharing? And beryl is an example of which type of silicate? Zircon is an example of which type of silicate? And spodumene, talc, quartz, feldspar, which type of the silicate? This is chapter from you can by heart, student. Compulsory need point of one question they will ask. Okay, students. With this this chapter is completed. That is group 14 elements. Okay, next continuation, students. Group 14 elements. Theory part is completed. Now we are discussing about objective questions based on KSET, JEE and NEET model. KSET, JEE and NEET model. We are discussing one by one, student. Very easy topic. Objective questions, KSET, JEE and NEET model. First question, student. Naturally occurring carbon containing two stable isotopes. The two isotopes are, generally carbon is available in the atmosphere in the form of three isotopes, students. Carbon 612, carbon 613, carbon 614 in the form of three isotopes. Among these three isotopes, the first two isotopes are stable isotopes, whereas the third isotope is unstable isotope because it is radioactive isotopes. Therefore, the correct answer is carbon 612, carbon 613 are stable isotopes. Next question, student. Second question. Which of the following isotope of carbon with the half-life 5770 years used for radiocarbon dating? Which of the following isotope with the half-life 5770 years can used for radiocarbon dating? Generally, student, carbon 614 whose half-life will be 5770 years. This carbon isotope, carbon 614, can be used for radiocarbon dating. That is, the age of the fossils can be determined by using carbon 14 isotope. Hence, this phenomenon is known as radiocarbon dating. In examination, they will ask student, which isotope can use for radiocarbon dating, or age of fossils can be determined by using which isotope? Student, carbon C614. Now, on technical level, half-life of C614 is 5770 years. What is the meaning half-life means? The time required to reduce initial amount of C14 isotope exactly to half of its initial value are known as half-life time or half-life period. The time required to reduce initial amount of the C14 isotope into half of its value are known as half-life time. For example, if carbon 14 isotope is 10 grams initially, then the 10 grams can be reduced to exactly half of its value within the time 5770 years. It is known as half-life time because the initial amount of the C14 isotope is reduced to half of its value. That's why it is half-life time. The time required to reduce initial amount of the C14 isotope into half of its value are known as half-life time. If 10 grams is there, 5 grams, 20 grams is there, 10 grams, 40 grams is there, 20 grams. Initially, how much amount is produced? That is reduced to exactly half. X grams is present, X by 2 grams will be required. X by 2 grams will be obtained in the half-life time period. Next one, excessive point, student. Similar to the radiocarbon dating, another method is there, that is uranium dating. By using this, age of Earth can be determined. The isotope will be uranium 92-238. Isotope can be used in uranium dating. to determine age of Earth. To determine age of Earth. Comparative student. Age of Earth, uranium dating. Age of fossils, carbon dating. Uranium dating you are using uranium-238 isotope. Carbon dating you are using C14 isotope. Okay students, next one. Question number 3. The small increase in the covalent radii from silicon to lead is due to. We know that in a group the atomic radii increases because number of shells increases. In the case of group 14 also the atomic radii will be increases, but the increase is very small from silicon to the lead. From silicon to the lead. 77 picometer to 118 picometers. Considerable increase is observed, but silicon to germanium, how much is only 4 picometers increases. From germanium to tin, small increase. From tin to lead, 6 picometers will be increases. Generally, the groups increase minimum 100 picometers, 100, 200, 500, like that the atomic radii increases. But from silicon to germanium, the increase in atomic radii will be very small. That is, a small increase in the atomic radii will be observed. Because the reason is due to presence of completely filled d and f orbitals from germanium to lead. Due to presence of completely filled d orbitals and f orbitals from germanium to lead. For example, student, from germanium, in the case of germanium, 3d10 completely filled d orbitals are present. Tin 4d10, lead 5d10, 4f14. In these three elements, completely filled d and f orbitals are present. Due to this reason, the atomic radii will be small increase will be observed. Why? Because due to the inert pair effect as well as due to the poor screening effect or shielding effect of the d and f orbitals. So many times we are discussing. As the number of inner shells increases, the inner shells can access poor screening effect. In the case of sp-df orbital, d orbitals are very poor screening effect. Hence, the nucleus tightly attract the valence shell towards itself. Hence, due to the poor screening effect, small increase in the radius of the group 14 elements will be observed. Clear, student? The reason is due to the presence of completely filled d and f orbitals from germanium to lead. Other option also expressed. Other option also is expected, student. That is due to the poor screening effect of the d and f orbitals. Due to poor screening effect of the d and f orbitals. Okay, students. Next one, question number 4. Question number 4. The tendency of germanium, tin, lead to show +2 oxidation state increase in the sequence. Here the correct answer is like this, student. From germanium to lead, tendency to show +2 oxidation state increases or +2 oxidation stability increases because the reason is due to inert pair effect. Due to inert pair effect, the +4 oxidation stability decreases from carbon to lead, whereas +2 oxidation stability increases from carbon to lead. +2 oxidation stability increases, +4 oxidation stability decreases. Now they are asking +2 oxidation stability, student. It is the correct order. From germanium to lead, the +2 oxidation stability will be increases. Therefore, B is the correct answer. Germanium less than tin less than lead, the +2 oxidation stability will be increases. +2 oxidation stability will be increases. Next question, student. Question number 7. Sorry, student. Question number 5. Carbon cannot exceed its covalency more than 4, but other elements of the group 14 can do so. The possible reason is presence of d orbitals in other elements. So many times we are discussing, student. In the anomalous behavior of the carbon having maximum covalency 4, whereas rest of elements silicon, germanium, tin, lead having covalency more than 4 due to absence of vacant d orbitals in carbon, due to presence of vacant d orbitals in other elements. Here only one reason is given, student. Presence of d orbitals in other elements. Presence of d orbitals. The same, instead of this, other option also possible. Absence of vacant d orbitals in carbon. Absence of vacant d orbitals in carbon. Therefore, the correct answer is E. Question number 6. Identify X in the following reaction, student. The given reaction is X plus 2H2O, that is steam, hot water. Heated, it can form XO2 plus 2H2O. Identify the element X they are asking. Identify X the element. Here X is known as tin. X is known as tin. We are discussing on reaction of steam with the group food elements. Except tin, carbon, silicon, germanium, lead does not react with water. The only element which can react with the steam is tin only. Here the X is equal to tin. Tin plus 2 molecules of water, it can form tin dioxide, SnO2 plus 2H2O. Tin dioxide, SnO2 plus 2H2O. Therefore, the correct answer is D is the correct answer. Next question number 7, student. Which of the following does not exist? Which of the following does not exist? Lead tetraiodide does not exist. Why? Because it can decompose to lead diiodide plus iodine due to inert pair effect. Due to inert pair effect. Just now we are discussing down the group plus 2 oxidation stability increases. Lead is more stable in plus 2 oxidation state, less stable in plus 4 oxidation state. In lead tetraiodide, the oxidation state is plus 4, student. In lead diiodide, the oxidation state will be plus 2. The plus 4 form ready to convert into plus 2 form because lead is more stable in plus 2 form than plus 4 due to inert pair effect. Due to inert pair effect. Hence, lead tetraiodide will be does not exist. Lead tetraiodide does not exist. Will be highly impossible. Will be highly impossible. 7th A is correct answer. Next question 8. Silicon tetrachloride react with water to form product which can react with A, it can form C. What are the A, B, C? They are asking student. When silicon tetrachloride with water to form SiCl3OH which can react with A, it can form C by the loss of some of the reactant. By the loss of some of the reactant. What are the A, B, C we have to identify? Here it is the NCERT textbook they are given, student. Very good question. When silicon tetrachloride react with water, it can form SiCl3OH. SiCl3OH. Here mechanism, student. Water contains H plus and OH minus ion. We know that water contains H plus and OH minus ion. The H plus ion react with chlorine to form HCl. It can lose as HCl. The hydroxy replace chlorine. The hydroxy replace chlorine. Therefore, SiOH Cl can be formed. Further, it can react with 3 molecules of water plus 3H2O. Here, each water molecule contains H plus because of 3 water molecules 3H plus ion. The 3H plus ion react with 3 chlorine atoms to form minus 3HCl. Remaining 3 hydroxy molecules bonded to the silicon atom. Therefore, SiOH 4 times. SiOH 4 times can be formed. Tetrahydroxysilane. Tetrahydroxysilane. It is having some commercial name that is known as silicic acid. Silicic acid. Silicic acid. In examination they will ask you, what is the formula of silicic acid? SiOH 4 times. SiOH 4 times. Therefore, here A is 3 water molecule, B is 3 moles of HCl, and C is silicic acid. SiOH 4 times. SiOH 4 times. Okay, students. Next one, question number 9. Carbon has unique ability. Carbon has unique ability to form p-pi, single bond, double bond, triple bond, multiple bond. Very good question, student. Carbon can form p-pi, multiple bond. We cannot define double bond, triple bond. Why? Because it has a unique ability. Sometimes in higher classes in your post graduation and graduation, you know that carbon can form quadruple bond also. C 4 bonds C, like C triple bond C, C double bond C. Hence, we cannot define carbon has unique ability to form p-pi, double bond, p-pi, triple bond. But carbon has the ability to form p-pi, multiple bond. That multiple bond maybe double bond, maybe triple bond, maybe quadruple bond also. Hence, here multiple bond is the correct answer, student, but not double and triple bond. Very good question. Next question number 10. Carbon is able to show allotropic forms due to catenation, p-pi bond formation, both A and B, none of these, student. It is the NCERT textbook. Clearly the reason is given, student. The carbon can show allotropy due to two reasons. One is catenation, next one is p-pi bond formation. We know that allotropy. The phenomenon of existence of same element in more than one form are known as allotropy. Diamond, graphite, fullerene are the allotropic forms of the carbon. Due to catenation and p-pi bond formation, carbon can exhibit allotropic forms. Copy this, student.